If you ever watched one of my project videos and thought to yourself, this guy has no clue what he's doing, I have to prove him wrong, then you had no choice but to gather the required components and connect them to one another on a piece of perf board according to my schematic. The process which we use to reliably connect components, jumper wires and practically everything else in the circuits is called soldering. And no matter whether you create an old school circuit with through-hole components or solder itsy bitsy surface mount components to a PCB, there exist useful guidelines which make soldering a breeze. So in this video I will present you my technique for both THT and SMD soldering tasks, which up until now never failed me. Let's get started. First off, let's have a look at THT soldering, aka through-hole technology. Around 99% of my created circuits use this technology since it is very simple and accessible. The things we need for it are the following: a piece of perf board with copper lines or dots. I personally prefer dots though, since you can create more complex layouts on a smaller area. The THT components according to the schematic of the circuits, which you can always recognize by the long leads, which according to the name of this technology push through the holes of the perf board and are soldered in place on the other side. And last but not least, a soldering iron, or even better, a soldering station, with a screwdriver tip or a conical tip, as well as obviously a bit of solder. I recommend using solder with a flux core, since it removes the oxide coating of the metals and thus creates a strong bond and a shiny surface, while flux-free solder is certainly a bit harder to work with. Since we got everything ready for soldering, we can turn on the soldering station, heat up the iron to 350 degrees Celsius and position the heart of the circuit, the AT-Tiny85, in the middle of the perf board. The package the IC uses is called DIP8, which stands for Dual Inline Package, and the 8 represents the number of pins. This DIP package is pretty popular with THT and only distinguishes itself through the numbers of pins used, but the soldering technique always stays the same. First off, we have to bend 2 pins on the copper side so that the IC stays in place. Then we bring our iron close to one pin, heat it up as well as the copper pad for 1 second, and immediately bring in the solder from the side so that it flows around the pin before we remove the soldering iron. After cooling down, the solder joint should have a shiny surface, which means we can continue by utilizing the same technique to solder the rest of the pins to the perf board. One thing that we miss though is the fact that you usually do not directly solder ICs to a perf board. It is actually recommended to use sockets, so that you can replace the IC in case it blows up. So to remove the IC from the perf board, I like to use so-called solder wick, which is basically copper wire coated with flux. To use it, we simply lay it on top of a solder joint, apply pressure with the hot soldering iron, and wait until we see the flux come out, which means that the solder wick sucked up the solder. This way we can easily remove the IC and replace it with a socket which we solder in place the same way as the IC. Now the rest of the components all follow the same soldering scheme, which is push the leads through the holes, bend them on the other side, quickly heat up one lead and the copper around it, bring in the solder and let it reflow for a second before letting it all cool down. And once enough components are in place, we can use simple solder lines or jumper wires to connect them to one another. Then we can repeat the process by soldering in more components and then connecting them until the circuit is complete. And if you think that this sounds rather simple, then you are absolutely correct, because it only takes a bit of practice and patience to master the art of THT. So now that our through-hole boost circuit is finally complete, we can have a look at a boost converter, which except for its potentiometer, only consists of SMD components. SMD stands for Surface Mount Device, which means there are no leads which pass through the circuit board. Instead, the components are directly soldered onto the surface of the PCB. That means the process of placing the components on the PCB and soldering them can be completely handled by a machine. Another advantage of them is their very small size, which is mandatory for circuits that need to fit in your pockets. And if we have a look at this LiPo Charge Protect Boost PCB that I created, we can discover the last advantage. The circuit consists of 4 different ICs, which, if we look at their datasheets, only exist as an SMD package. That means if you want to use the newest IC technology, you should get familiar with SMD or get out. It's as simple as that. So let's bring in the components for my circuits and let's get started soldering. I always like to start with the Schottky diode and the inductor, since their solder pads are located underneath them, so that traditional soldering is pretty hard to do. Instead, we can use so-called solder paste. By firstly securing the PCB to the workplace, we can squirt a tiny bit of the solder paste onto the solder pads, push the components in place with a tweezer, and then grab our hot air station. By selecting a temperature of 300 degrees Celsius and a medium wind speed, we can heat up the solder paste until it turns liquid and then into the usual solder, which pretty much automatically sticks to the component and solder pads and locks it all in place. Now, of course, you could use the solder paste / hot air technique to solder all the components to the PCB, and the result would even look better than with a normal soldering iron, but I still do not favor this method. The reason is that you can more easily overheat a component. In my case, I destroyed my boost converter IC, which I had to replace before the board could function correctly. So let's use the soldering iron instead, whose screwdriver tip I replaced with a very fine conical tip. When it comes to SMD components with 2 terminals like resistors, capacitors and LEDs, we firstly tin 1 solder pad, move the component to the pad with a tweezer and reflow the solder so that the component gets secured. Then solder the other side in place and add a bit more solder to the side we started with. Afterwards, we can repeat this process for all the other 2-pin components. Once again, practice is everything. And as you can see, I do not have the steadiest hand. But even like this, it is no problem to solder SMD. For further assistance, you can even use a microscope like I do right here, which makes soldering a lot easier. But even without it, I successfully soldered a complete board, which afterwards functioned without a problem. Next, we got the SMD ICs, which I talked about earlier. My technique is to tin 1 solder pad, position the IC with tweezers while utilizing this pad to lock the IC in position, and then simply solder the rest of the pins in place, just like we did with the through-hole IC. Of course, the smaller your IC gets, the more difficult it becomes to solder all pins properly. But once again, the technique stays the same. It only takes a bit of practice. Last but not least, I soldered the micro USB port and the switch in position, and our SMD circuit was complete. But we have not faced one of the more popular SMD packages yet, the TQFP, aka Thin Quad Flat Package. Your Arduino Pro Mini or Arduino Nano, for example, consists of one of them. To solder them, you must firstly align them with a diagram on the PCB, then solder 1 pin in place and get the IC in position just like we discussed it earlier. Afterwards, we can solder 1 pin on each side to the PCB. At this point, we should get ourselves a flux pen, which we can utilize to flood all the pins of the IC in some additional flux. Then we add a ton of solder to all the pins so that they are basically all bridged on their corresponding sides. And finally, we can use solder wick to remove the excess solder and afterwards utilize a cotton pad with some isopropanol to get rid of all the excess solder material on the PCB. And just like that, you can easily solder an Atmega 3208P microcontroller to your PCB without creating any shorts. Now the last SMD package we want to have a look at also comes in the form of an ESP8266 IC, which I removed from its breakout boards with hot air. As you can see, it has no leads, only contact points on the bottom side. That is why this package is called QNF, aka quad flats, no leads. But surprisingly, soldering it to a PCB is pretty much the same process as before with the GQFP. The only difference is that you cannot easily see whether your solder connections were successful or not. In my case, I did a pretty horrible job right here. But anyway, with that being said, you are now ready to solder all kinds of through-hole and surface mount components. And if you want to use the same tools/materials as me, then you can check out the video description where I listed all of them. As always, I hope you enjoyed watching this video. If so, don't forget to like, share and subscribe. Stay creative, and I will see you next time.